Hello, my name is Carolyn Robinson, and during this presentation, I will discuss improving STEM learning environments through the use of augmented reality. Let me begin by providing some definitions for the audience. The United States National Science Foundation coined the term STEM in 2001, and the acronym has widely been used ever since to describe fields of science, technology, engineering, and mathematics. The term augmented reality, sometimes just listed as AR, describes a combination of technologies that enable real-time mixing of computer-generated content with live video display. In essence, AR takes a virtual image that can be often manipulated and places it in real time with the use of a mobile device, which could include a tablet, a phone, or a computer. For the purposes of my presentation, I may use AR for a simple term or augmented reality as a longer term. Let's take a look at some examples. There are mobile phone enabled AR stickers. One example here is of an AR sticker that my friend who has a flagship mobile phone was able to record directly from his phone and send to me. This would be considered an AR sticker. Then there are augmented reality cards. The AR cards are another use of the augmented reality technology. In this example, the card is viewed by the camera and an image comes alive on the screen. Another example of an AR card is where you can actually color the image and the picture picks up the color from a regular crayon or a colored pencil, just as though that color was initially part of the image. This next example is also an AR card. These little creatures appear on the wall right in front of the user as though they are sitting there and can be manipulated from the screen. Then our next example would be what is called an AR merge cube. The merge cube is just a three-dimensional block, and it interfaces with the tablet and can show a variety of images once the camera on the mobile device comes in contact with the image. This example shows a set of lungs, and then with just a touch of the screen, a brain advances onto the screen, and picking up the cube is like picking up the actual brain as it shows up in 3D on the screen in front. One could also investigate the solar system. By just a tap of the screen, you can watch different planets rotate around the sun or investigate further to see more information on a particular planet. The Merge Cube also comes with Apple and Google Play enabled apps, which allow a user to investigate other items. In this example, it appears that the user is holding a castle in her hand, in which a touch of the screen, fireworks explode. Let's discuss the benefits of augmented reality. There are two prominent educational theories that I'd like to review before I talk about some of the benefits of augmented reality. Constructivism is an educational theory concerned with how people learn, and the adult learning principles of Malcolm Knowles is also an adult learning theory for which self-directed inquiry is the underlying tenet of the learning philosophy. Constructivism focuses on students being actively engaged in their environment. That could be some collaborative activity, manipulatives, or kinesthetic activities. The andragogical principles of Malcolm Knowles encompasses 4 learning ideologies that assert adult learners are motivated to learn when 1, they are involved in the planning and the evaluation of the instruction, meaning that they have the opportunity to explore the topics that are being investigated, and they select those topics which are of interest to them. Second, adult learners are motivated to learn when their life experiences, which include successes and failures, are utilized to provide the basis of learning activities. Integrating these experiences into the educational experience can make the learning more effective and meaningful. 3, when the adult learner, sees immediate relevance and the direct impact for applying the learned information, which generates the most interest for learning. And 4, there is problem-centered learning, and that's more relevant to the adult learner than content-oriented learning. As adult learners acquire new knowledge, effective application of the new information produces more efficaciously beneficial retention of the learned information. Augmented reality can help enhance these learning environments, creating active and immersive learning environments through the use of nascent technologies such as augmented reality and virtual reality. These are catalysts to achieve these meaningfully focused educational environments. Learning with augmented reality and virtual reality technology tools would enable increased understanding of complex issues, seamless knowledge seeking and acquisition, and recurrent engagement through manipulation, activation, and collaboration. Augmented reality can be used to change current, very static learning environments to active, engaging learning centers. The benefits of augmented realities, as I discovered in the research, indicate there's increased motivation, attention and concentration, learner satisfaction, interactivity, communication, and collaboration, and also improved learning time, spatial abilities, and enhanced memory. The studies show that augmented reality can support a student-centered learning approach by providing educators with new possibilities to individualize their lessons according to students' capabilities, and by enabling students to learn more independently from educators. The future of augmented reality in education is awesome. During my research, I found 2 companies in California. One was called AR STEM Labs. They focus in on technical education in teaching electronics and circuits. Here is a brief video to show you some of the things they do. Another company I discovered was Z-Space, as an augmented reality company also located in California, and they do primary education and career and technical education.
Light the glasses that you're wearing. And the first pair of glasses I'm going to talk about are called tracking glasses. The tracking glasses have these little sensors, these little white dots, glasses on my frames. And those glasses are going to interface with my computer screen. So look at the monitor here behind me. What do you see happening? It's moving. It's following my perspective before I'm looking in the computer. And that's happening because if you look at the computer around you, you're going to see 2 red dots on each side of the monitors. Those are actually cameras. Those cameras are interfacing with the sensors to give me that 3D view when I'm looking at this picture. The other equipment that we're going to use is our stylus. And our stylus is basically a mouse in a pen format. I'd like you to hold it like a pen, because both ends of the stylus also have to be in view of those red dots. I'm going to put my index finger on that front round button. I'm going to hold the stylus about 6 to 8 inches away from the screen. But look here, you'll see that tracking line. When it's within range of my object, I'm going to press the front round button to pick it up and be able to interface with it. So I can knock other things out with this and do that. If I let go of the object, it has gravity and it will fall. Okay, I'll do that again. Like another chess piece. That, I let go of the button, it falls. Other objects, however, will suspend. So that chessboard, I can bring it out and I can turn it and it will stay there until I come back to it with my stylus, pick it up again, and move in any direction. I can back, side, see where I want to go. And when I have it in Z-Space, you see how the chessboard has left the computer screen? See that there? I see that in 3D right here in front of me. It's just a camera. All right. So that's the tracking glasses and the stylus. These go together. I stand right in front of the computer to make that happen. The other pair of glasses that your partner is going to use, we call our follower glasses. And the follower glasses just polarize the screen like when you see a 3D film. You take the glasses off in a 3D film, what happens? It's all blurry.
The next video allows us to take a look at some of the features that are presented with the Z-Space augmented reality information.
Bring up that part, bring it out towards your tongue. What are you feeling? Yeah, you feel the heart beating. Right. So, bring that part out towards you a little bit later. Let go of the stylus, let go of the button, and slowly push your head into the model. Another 2. And look around, and what do you see? Yeah, you see the valve inside the heart. The other way you can see inside the heart is the back left button on your stylus.
There are a number of opportunities for growth within augmented reality. In Spain, they're using augmented reality to help with visual spatialization. So they are creating augmented reality notebooks, as you can see in the figure shown here. Additionally, there are a load of opportunities for developers to create content specifically for STEM majors and STEM subject areas. So those would include physics, statics, dynamics, strength of materials, and upper and lower division technical courses. AR will enable instructional designers and educators to create rich environments for active learning and update, improve, and enhance students' learning experiences. I'd like to thank the individuals at Z-Space and my daughter for assisting me, and I would like to thank you for watching.